Hello there, this is Anthony Johnson, and this is episode 8 of SQL Interview Prep. What are joins? And what are the different type of joins? And how do they operate? One of these three questions, and or all of them, may be combined when asked this. This is a common interview question. Joins are the lifeblood of SQL. You could do a lot of things in SQL, but joining multiple tables is pretty common, and it is, like I mentioned before, it's the lifeblood. So you would say you have your inner join, your outer join, your full join, and or full outer join, your left join, your right join, or they can be left outer join or right outer join. Those are the same as left and right join. You just cut down on your spelling. Both execute the same way, so don't let the entrance of the word outer when talking about a right outer join like interfere with your thinking pattern, because it's the same thing. You have your self join, you have your cross join. Another term for cross join is Cartesian product. And then you have your join substitutes, which work for table value functions, which is your cross apply and your outer apply. So let's see here what we have. Our first one is an inner join. So the two tables are joined on a common column, which is manager ID and manager ID from both respective tables. And it brings back the corresponding data, as you can see there. So it's a regular join which combines both tables and only returns back the matching data based on our on clause. Now let's do our left join. Still same thing, you have to have your common column, but it returns everything on the left table and only the corresponding data from the right table. What do I mean by that? Just the positioning inside of the from clause. So you see, this is considered the left side and this is considered the right side. So now let's go down to our right join and our right outer join, as I was saying. Now it's the opposite. Everything from the right side of the table, and only the corresponding data from the left side. So let's see. We have the M, which is our right table. In this case, we want all the names. We have their names. These are the manager names. And then we want to return all of the other columns from the E table, which is the left table. So if these people correspond, the employees correspond with these managers, then it will return data. You see here we have null because we have a manager in this table, but he hasn't been assigned a department. So it's going to add additional nulls in those columns because he doesn't have anyone working under him. So that's how that goes. Our full join. And as you can see here, it brings back the data from both tables, no matter if they match or not, essentially. So like I mentioned before in the previous right join, we still have this same manager here, and he doesn't have anyone working under him, but it still brings back nulls from the respective columns. That's your full join. It's going to bring back data, all the data from both tables, regardless of the on clause. So now we have our cross join. So you can write your cross join two different ways. You can do it like this: employees table delimited by a comma, or you can actually write employees tech company, which is the table I'm using, cross join, and then put manager tech company as well. That's the table I'm using. Whatever your two respective tables are, you can add cross join, or you can do it like this. Now let's see what this does. Okay, 32 records. Okay, so what it essentially does is it multiplies all the records from table A by all the records in table B. So table A has 9 employees. No, it has 8 employees. And then the managers table has 4 managers. So it multiplies all 8 of these employees, because you can see they repeat, and it multiplies it, and we get 32. 8 times 4 is 32. And as you can see, it assigns every employee, each manager that's in the list. And you see Anthony Russell, which was the manager that has no one that works under him, he magnificently, or just mysteriously, has 8 employees, which is not accurate. So cross joins are definitely looked down upon. They can be resource intensive. Imagine if these two tables had millions of rows in them. That would take a lot of CPU power. Okay, so now we're gonna get down to our self join. I did a video on cross apply and outer apply. It's inside the playlist, so if you could check that out, that would be very appreciated, and hopefully you get some value from that. But lastly, we're on to our self join. Now we're going to highlight both of these and execute them. Okay, let me just, for good representation. Okay, so this is our employees table. Let me back up a little bit. Self join. So it just gives you the ability to join to the same table. Aliases are very much enforced because you will get ambiguous columns in your select list, and that will always throw you an error. So essentially what we did here was join our employees tech company table to the employees tech company table. But as far as our ARM clause, from the base table, we chose the manager ID, which if you look down here, this is the table that we're joining each other to. Itself to. My apologies. We're taking the manager ID from the base table, which is right here, the left table. And then our right table, we're taking the employee ID. So we saying on our ARM clause, we want the manager ID to equal the employee ID. Okay, so this is the result set right here. Result set. And then this is the employee table by itself. So as you can see, employee Tony Howard, his manager ID, his manager ID is Rod Jones, and you can see the manager number is Rod Jones. For Rod Jones, his employee ID is 2, which here is 2, which is Tony Howard. So Tony Howard is his manager number, which this may seem confusing, and there's plenty of other videos out there. I tried to come up with a better example to show you guys this, but it's just I wasn't able to put the data together. But essentially it gives you the ability to join to itself. It's not really commonly used in the tech field. Typically a recursive CTE is the alternative to this, and that's more so used than anything. You can also use a while loop, but that you have to be very particular with your while loops because things can spiral out of control. But as I mentioned before, cross apply and outer apply, I have a video in the playlist. You can check that out. And just to reiterate what I said, the question is, tell me about joins. What are the joins? You have your inner join. Your inner join returns data from both tables that corresponds with each other based on the on clause. So if you have 100 rows in one table and 100 rows in another table, you join them together using inner join. Only the records that correspond with table A and table B will be brought back. No additional records. You have your outer join or your left join. Your left join is going to return everything from your left table and only the corresponding data from the right table. You have your right join, and it's just the reverse of the left join. You will return all the data from the right table, only the corresponding data from the left table. And anything that's not corresponded to it, if it doesn't correlate, then it will be a null in that column. Bool join, it returns the data from both tables, no matter what the on clause is. A cross join is simply a join without an on clause. You can also write cross join here, opposed to having a comma separated in the from list. Then you have your self join, which you can also use a recursive CTE to achieve the same results, and it makes more sense, and I prefer it over a self join, but that's neither here nor there. Self join just gives you the ability to join to that same table. It's typically used on hierarchy data. Typically, the primary key and the foreign key is within one table. That's one of the indicators that tells you that perhaps you want to use a self join. So this was Joins, episode 8 of SQL Interview Prep. I hope this was helpful. Hope you guys have a blessed day, and bye-bye.